What is permafrost? Well, permafrost is rock, soil, below the temperature of 0 degrees Celsius, known as the freezing point of water, that has been in the condition for 2 or more years. Permafrost is most likely found at high latitudes, but also can occur at higher elevation at lower latitudes, such as mountains. A huge amount of organic carbon is stored in the permafrost in the Arctic and the subarctic regions. A warming climate can cause environmental changes that accelerate the microbial breakdown of organic carbon, which would release greenhouse gases such as carbon dioxide and methane. This positive feedback can accelerate climate change. The magnitude and timing of these emissions and its effect on the climate change remain uncertain. Current evidence suggests a gradual, steady release of greenhouse gases and a warming climate. The paper itself presents a research strategy to target poorly understood aspects of permafrost carbon dynamics. At high latitude regions, the temperatures have risen by 0.6 degrees Celsius per decade over the last 30 years. That is twice as fast as the global average. This is causing normally frozen ground to thaw, exposing a large amount of organic carbon to decomposition by microbes within the soil. The permafrost region contains carbon from plants and animals accumulated in perennially frozen soil over thousands of years and contains about twice as much carbon as there is in the atmosphere within the present day. Conversion of just a fraction of the carbon pool into greenhouse gases, carbon dioxide and methane, and their subsequent release into the atmosphere would have a noticeable impact on the rate of climate change. The critical question is, how fast will this occur? There is a range of viewpoints, but the abrupt release of greenhouse gases is forecasted to cause $1 trillion of economic damage to the global society, versus a slow, gradual release which would give time for society to adapt. This uncertainty can be linked with the lack of understanding of processes that only now is being quantified in these remote regions. The objective was to use new insights from a multi-year synthesis of data to improve the current understanding of the permafrost feedback to the climate, and providing a framework for developing research initiatives in the areas with permafrost. The first step was to review new research on the size of the carbon pool in the permafrost region. This research has enlarged the depth of knowledge in the permafrost region itself, confirming the tremendous quantities of carbon accumulated at depth in the permafrost. Furthermore, looking at permafrost soil samples over a period of time, a substantial amount of organic material can be converted to carbon dioxide and methane by microbes on timescales of years to decades, contributing to near-term climate warming. Abrupt thaw processes are common in northern landscapes, as seen in field observations. Mechanisms involved with the thawing of frozen ground and the release of permafrost carbon dioxide is unaccounted for in large-scale models used to predict the rate of climate change. So what does this all mean? It is likely that greenhouse gas emissions from a thawing permafrost will occur at magnitudes similar to historically important biosphere carbon sources, such as land use change, but will only be a fraction of the current fossil fuel emissions. The current estimates suggest that CH4 methane and CO2 carbon dioxide from the thawing of permafrost is unlikely to cause abrupt climate change over a period of a few years to a decade. Instead, the effect of emissions from a thawing permafrost is likely to be felt over decades to centuries, as the northern regions warm, making climate change happen faster than what we are currently predicting using climate models. This improved understanding on the permafrost emission timing and magnitude need to be integrated into policy decisions regarding the management of greenhouse gases in a warming world. But at the same time, it can put to rest the worst fears about the impact of greenhouse gas emissions from the warming of northern high latitude regions.